If we want to draw an electrochemical cell, we might have a figure like this where we have two beakers connected by a salt bridge, which is right here, as well as a wire. So this is how we're going to diagram an electrochemical reaction. So say we have the reaction of copper ions plus solid aluminum goes to aluminum ions and copper solid. Which one of these, what is, I should say, our oxidation half reaction? So aluminum goes from an oxidation state of 0 to an oxidation state of 3+, making aluminum to aluminum 3+, our oxidation half reaction. The reduction half reaction then is copper 2+ going to copper solid. So it's important to note that oxidation always happens at the anode. So I'm going to arbitrarily choose for the anode to be on the right side in this drawing, and my cathode to be on the left side. I could have chosen otherwise, it doesn't matter. So now let's begin to put our reactions onto their respective electrodes. So the oxidation half reaction happens at the anode. So we said this was aluminum solid goes to aluminum ions. If we were to balance that, we would also need 3 electrons on the product side. So this means that our actual anode, the solid, is going to be the aluminum solid. And we'll have aluminum ions in solution, most likely with some sort of counter ion, maybe nitrate. Maybe this has been dissolved as aluminum nitrate. And electrons will flow through the wire up here. So if we're thinking about the flow of matter and the flow of charge in our reaction, we start at the aluminum solid and we form aluminum ions in solution. And we start at aluminum solid and we form electrons. So electrons are flowing towards the light bulb in the wire. Now let's go to the cathode side and try to do something similar. The cathode, we have the reduction half reaction. This is copper ions goes to copper solid. In order to balance this, we need 2 electrons on the reactant side. So now our cathode, again, the solid metal material is going to be our copper solid. In solution, we have copper ions, maybe with a counter ion of nitrate. And then we've got our electrons in the wire. If we're following the arrow in our reaction, we start at copper ions and create copper solid. And we start with electrons and we go to producing copper solid. So we have this flow of matter and charge. So we'll see over time that the anode, right? Remember that the anode over here is losing mass. So the anode, if we were to weigh it or mass it over time throughout the reaction, it would actually be losing mass. Where the cathode, right, pointing into the solid, would be gaining mass as this reaction happens. All right, one more thing we're going to put in here is our salt bridge, which I have highlighted right now in yellow. So that's the one thing we haven't dealt with. So our salt bridge is just that. It's made up of a salt. We can choose any salt. I'm going to choose potassium chloride for this video. So say we've got potassium and chloride as a solid in its solid salt form is making this bridge, and it connects to both beakers. And so if we're over at the anode, we see that we're gaining positive charge in the form of aluminum ions into the solution, even though the nitrate ions, the negative charge, are staying the same. We're not gaining any more of those. And so as we gain more positive charge in the solution, we need to balance that out. So we might say that we need chloride ions to come from this salt bridge to balance the aluminum. So there's a balance of charge and a net of 0 charge in the beaker. On the other side, we are losing positive charge while the negative charge is staying the same. So we might say that we are gaining potassium ions from the salt bridge in order to balance the solution. Another way to think through the flow of ions through the salt bridge is to map it to that of the electrons. So we see our electrons here, they start at the anode and they flow through the light bulb and then into the cathode. And then we can think about the electrons or negative ions flowing through the salt bridge in this direction and all the way back into the anode beaker. And so our chloride ions, being negative, match that flow of negative charge. So they make a full circuit if we were to keep going. Whereas when I drew the potassium ions on the side, the arrow is facing against the flow of negative charge because potassium ions are positive. So we should see that sort of pattern. And that's how you would label and diagram an electrochemical cell. This is known as a galvanic cell because this reaction is happening spontaneously. There's no input of electrical current.